Yeah, welcome to this 49th CRE talk. We are fortunate to have Professor Ravi to deliver the talk today. As most of you know, Professor Ravi is the director at NIT Karnataka, Surathkal, and he uh, is an alumni of NIT Rourkela and IAC. And earlier he was working at IIT Bombay, and as part of his work at IIT Bombay, he has been involved in quite a few initiatives. Couple of very notable initiatives being the setting the e-foundry ecosystem and also the BETIC biomedical engineering technology innovation ecosystem there. He was also the head of the Desai School of Entrepreneurship, and recently he has published a book summarizing his experience in connecting research with education and entrepreneurship. So we thought this will be extremely relevant for all of us, especially the participants who are going through the capacity building program on design and entrepreneurship as well. So it will be a great talk for all of us to listen. I've also requested Professor Ravi if you could join some of the pedagogy workshops that we are planning to do as part of the program. So with this background, let me welcome Professor Ravi. We will have the presentation first and then the Q&A in the last 20 minutes. Over to you, Professor Ravi.
Yeah, good evening and good morning to everyone. And a special thanks to Professor Sudhir for inviting me. This is going to about 40 minutes odd session. I'll be talking, but it's not just talking. I'll be kind of connecting a lot of dots and also throw in a story from my own life, which connects many dots. Of course, I think if it's possible, I'll request Professor Sudhir to let all of you keep commenting or putting questions on the side as it comes to you. And I'll request him to collate and maybe ask at the very end. That should be, I think. Get up. All right. Okay.
Yeah, we can see.
All right. So thank you once again, and let's start the session. So as I mentioned, we'll talk about connecting research, education, innovation, entrepreneurship. Usually for faculty in technical institutions, engineering, science, technology institutions, these four are seen as four different aspects. Most faculty, when you ask them, why did you join the institute? They'll say primarily research. Some of them will say, no, we love to teach, so we joined that. And these two themselves are seen as a zero-sum game, which means that if you spend more time in research, you have little time, less time in teaching and so on. And now the expectations have increased and faculty are supposed to look at research translation into innovative products and processes and even mentor aspiring students as startup founders. So these four are looked at upon as pulling in four different directions. And the question is it possible to even do all of them? Do we do it efficiently? Is there any golden formula for doing that? These questions we will kind of answer. And as Professor Sudhir mentioned, I bring to table my background in mechanical engineering, having done a lot of software coding, which is software being used in industry, and then 3D printing, manufacturing, metal casting, medical devices, medical software as well. And my last stint at IIT Bombay was as the head of the School of Entrepreneurship. So these have given me some perspective about the best practices and some, we can say, wisdom about how to connect these. I hope everyone will find something interesting, useful in this session. And as I said, I'll throw in a story as well. Before we go further, let me use a quick invocation or prayer saying that I'll just use the English version saying that let's all enjoy this session. Let's focus on this learning together. Let's apply our energy and let's have some good insights. Please do make notes and share with us. And of course, no misunderstanding among any one of us or about the learning. Incidentally, the picture which you see on the top is itself an interesting project where we start from a palm leaf drawing of a Ganesha, the first one on the left side, and use a mix of modern and ancient technologies, including haptic CAD or 3D modeling and 3D printing and investment casting. And I like to use the mouse because if you look at Ganesha as not only as the one who removes obstructions and obstructions even for learning, but the fact that his vehicle is a mouse puts its own twist, as mouse as a gateway to many of our knowledge resources. So what will we do in this session? One, we will talk about the context, and the context is basically what are the current and changing priorities of the academic institutions. And the second context is what do we do? What is our overall goal of as academic institution? Do we have the potential, realizable potential for social and economic impact? With that, we'll talk about these four aspects. Basically, how do we initiate or carry out meaningful research projects, which leads to R&D funding, which is good for the institute? How do we inspire our students? How do we make them valued professionals, which make them employable? And third is how do we convert or translate our research into interesting, viable technologies, which leads to patents and more importantly, licensing of the patents. And fourth is how do we spot and mentor students who are aspiring to be entrepreneurs or startup founders, including intrapreneurs. Companies do need innovative thinking people. And how do we connect these four? And that's how I take the title of the session as Reinvent, taking the letters of those. And more importantly, we also look at how the two bridges can be built from research to translation into innovation, and from education and inspiring the students to mentoring them towards entrepreneurship. That's overall picture of the session. And we'll go into that sequence. Now let's talk about our customers, which is our students in some sense. And if we look at students, basically what? I mean, they will finally look for jobs in academia, a small percentage. Some of them will even look at public service and maybe their own passion. And the engineering is more like a safety net or a degree to have, but the real passion could be in arts, media, or sports or something like that. But the majority, of course, will look for jobs in industry or business. And that brings us to, let's say, four kinds of maybe companies that they aspire for. And depending on the size of the company or the level of the technology, we can say maybe they will look for maybe MNCs, which are high paying, but also a little bit risky in terms of hire and fire, or PSUs, which of course have very stable jobs, but may not be very high in technology, with some exceptions, of course, like ISRO or DRDO. And on the other side, startups is becoming very, very, we can say, commonplace to think about at least. But the new kid in town in terms of options, employment option is gig work. It is suspected and projected that many students will not even look at startups, but gig work, which is a one man or one woman consulting kind of a company. And typically they call it as a learn, earn, burn, and repeat cycle. But with the whole context, as faculty, we have to worry about what kind of systems and teaching and curricula and pedagogies we should put into place that students coming out in 4 or 5 years from now, by 2030, they are prepared for their preferred placement options. That's a question that we all have to think about. On the other hand, let's think from the point of view of the teachers as well. This cartoon was made by one of my colleagues at IIT Bombay. But if you look at faculty in general, the kind of work that we do, we can call it as academic or non-academic, or internally focused or externally focused. And by and large, you will see 4 groups of activities. Internal academic work is primarily teaching research. The same thing, little external would be maybe continuing education or conferences. On the other hand, somewhat non-academic will be like administration or creating infrastructure. And external could be like consulting or expert committees, advisory committees, and so on. But with all that, again, the question comes, what really is the swadharma of engineering teachers or technology teachers? Is it only teaching? Is it teaching plus research? Is it teaching plus research plus innovation, or even entrepreneurship? What really is our core swadharma? And that's again a question which itself the answers may be changing, and it's good to keep that in the focus. But it's quite getting clear by now that the expectation of the students and parents and government and industry and overall society is that technical institutes must do much more than teaching theory. They must practice as well. And practice means that can we take the research, convert into something meaningful, product or a process, and take it to the market and actually create or display, demonstrate impact, social and economic impact. But that is a long journey, and one has to understand the pathways. And so if you look at academia on one side and industry or society on the other side, starts from a problem or a concept, and then you take it to the proof of concept, typically in R&D lab by a researcher, and the output could be a technical paper which is published. But that's not a good place to stop. If you can take one more step ahead and convert that proof of concept into a working prototype, and most colleges do have a prototyping centers, and it could lead to a patent, great thing, okay? And engineers could be involved in that. And most institutes usually stop at that. And you can see that TRL at the bottom, which is mapping to this from TRL 1, which is concept and 2 to POC to prototype, you come to TRL 4 or so. But then if you can take the next step and convert the prototype, which is a 3D printed part with some loose hanging wires, there's a breadboard. If you drop it, it'll break or not work. Now, can we convert into a minimum viable product, something that works? You can demonstrate that, you can make it in a small numbers, 50, 100, give it to people to actually to use or maybe even pay for it. Okay, that's a product. Okay, and that is possible to do it in an incubator. And a startup is typically what is a place where you convert a prototype into a product. And that's how an aspiring entrepreneur is born. But then startups is not the end game. Can you do scale up? Okay, take the product to market. And that requires financing. You set up the factory, equipment, hire people, you set up your supply chain and distribution channel, and then that's what is your, and you make money out of sales. That's a successful entrepreneur. In this whole journey, of course, for 1,000 papers, if you can file 100 patents, and for 100 patents, you can have 10 startups and one scale-up business success story. I think that's a great thing. The numbers are, of course, just to demonstrate that there's a scale involved in that from beginning to end. And also one has to remember that the amount of funding that you require is in the other proportion. You can build a prototype for maybe 1 lakh, but by the time you go to build a business, you may need an investment of several crores. And we'll talk about that a little later again. So with this background, and want to remember that the third value of death, from prototype to product, is a classical boundary between institutes and industry. And that's where if you don't cross that in a good way and build the strong bridges for doing that, many ideas will just perish there. And that's one place where we have to really focus. So let's talk about the 4 aspects of this session, starting from research. And let me start by saying that how do we really do research in academic institutions? So if you look at, we have used our intellect, I would say that essentially theoretical mindset to differentiate knowledge. From engineering, we go into civil, chemical, electrical, mechanical. We subdivide mechanical into design, thermal, fluids, manufacturing. Manufacturing, you divide again into casting, welding, forming, machining, and so on. And I can go on further on that if you want. But that is not how the industry looks like. Industry is called as a vertical and they have a practical mindset. They don't care about a product belonging to mechanical or chemical or civil. They integrate knowledge from different domains to finally deliver a solution to a particular, let's say, sector. And until we match these 2 mindsets, I think again, the classical difference between academia and industry, we cannot bridge that until we recognize that there is the way of looking at it. And until the academia also, at least some part of the academia, some faculty, need not be everyone, start thinking about, hey, we'll take the charge of knowledge integration and delivering solution. We really can't move forward onto that. And it's interesting, if you look at statistics, and this is about 3-4 years back, patent filing in India. Of course, as e-vehicles were coming up, a large number of patents were being filed into transport. And of course, software computers is always hot. But if you look at it, the medtech, biotech, pharma tech, and food tech as an area, and all of them are interdisciplinary. In fact, those patents are far more than even the medtech and computer tech. In fact, as an example, if you just take biology and say plus X, and you put anything as X, you have a hot, interdisciplinary, very, very interesting and very potentially an area for where you can get a lot of ideas and projects. And of course, you can take them to industry and create success stories. So there is interest, there is a lot of potential in the intersections between disciplines, and that one has to recognize, because faculty are in their silos, right? And And when people say that, hey, we have interdisciplinary mechanical faculty talk to electrical faculty, no, we're talking about engineering faculty talking to bio faculty, talking to management, talking to architecture, talking to poets and finance. That's what we mean by interdisciplinary. So we created a framework for faculty mindset to be going in that direction. And we say that the 4P framework, where you start with a proposal. And we said, don't write a proposal by looking at the research papers or talking to some faculty in some conference. Actually, go talk to the people whose problem you want to solve. Go to the field, ask stupid questions, open questions. And even don't start proposal immediately. You talk about it in your class, discuss with the students, tell your stories. Some student will say, can we not do like this? Encourage them to come up with a prototype, okay? And then you formulate a proposal, and of course, this can again go into a more formal proposal, funded proposal, and as you keep computer audio while you're sharing, there is no audio in that, Professor Sudhir.
Yeah, we can't hear any. Is there a recording there?
No recording at all, but you are able to listen to hear me. My
Yeah,
voice?
yeah, we are able to listen to you.
Absolutely. There's no sound in my video. Don't worry about
Okay.
it. All right. So if you keep doing that multiple times, then you establish a track record for doing that. So let me take just one aspect of that, which is proposal. Having seen a very large number of proposals across multiple committees, across multiple ministries, I feel many faculty still get confused between the research approach and methodology and things like that. And to make it very simple, I say it is like a journey. And what you see in the picture is, for example, the southern and western face of Kailash. So if you say you want to go to Mount Kailash from, let us say, I'm in Mangalore now. So you say, okay, I'll take a train from Mangalore to Bangalore, take a flight, then I'll go to Delhi, then I'll take a flight to Kathmandu, then I go to the Nepal-Tibet border, which is Kodari, then I go to Nyalem, then I go to the Mansarovar, then I go to, Kailash on foot or on ponies. So Kailash in this case is like the goal. So your project title or the goal should essentially say, this is what we want to achieve. And this Mangalore or Delhi or Kathmandu or Mansarovar are objectives. So you break down your goal into typically 3 or 4 or 5 objectives for a 3 or 4 year project. Not too many. If anyone sees 8 or 10 objectives, then it's already your chances of proposal are low. Nor just 1 or 2 objectives. That also is very low. Then methodology in this context of proposal is like mode of travel. So I said train and flight and maybe bus and maybe car and pony. That's how you write the proposal. Hey, I am going to go from this objective I'm going to achieve like this. And the work plan is a finer activity. So you say, I'm going to go to train station, buy a ticket, or go to IRCTC, buy a ticket. The work plan is a fine activities to achieve that leg of the journey. And then, of course, milestones are progress indicators. I reached T3 in Delhi airport, which means that is one milestone is over. And you don't look back, you can look forward after that. Timeline is obvious, duration of each leg. And you can put a deadline saying I'll reach by this date. And deliverables are success metrics. So you may say in this case, you say, I want to see Kailash, or I want to experience the thing, or whatever you want to put, where the funding agency says, okay, these metrics tell us if the project has been successful. And finally, the budget, what are different heads, and you have to justify the heads. There has to be correlation between what you propose in terms of funding and then what you actually want to do. If you want to know the secrets of how these get really funded, and these are the secrets of the reviewers. And if you really want to improve the success rate of your proposal, well, just think about this. Make sure your proposal is relevant to the scheme. If the scheme says it is for women scientists and your gender is male, well, that goes out of into the basket immediately. These days, the multidisciplinary, multi-institutional projects are preferred. Are your objectives and work plan very clear? Is it new compared to the previous work, and not previous work in your lab or your institution? Previous work anywhere in the country, not even country, anywhere in the world. Is it feasible to achieve? If you promise the moon and the reviewers feel that it is not possible, well, then it's not, your probability of success goes down. And more importantly, overall impact, if there are multi-institutional or multiple PIs, multiple investigators, is everyone's role very clear? Does every investigator have a track record in that area of work? And how is the track record? Okay. Do you have any commercialization partners? Even letters from industry partners saying this project is very important, we are having a problem, and this solution will be great to us, we will be happy to license it. Fantastic. If they put some cash or kind on table, even better. And finally, the budget. So many times we joke that this looks like a shopping list. If your equipment is going to be used once in a year, well, you're not going to get that equipment. So it has to be at least 50, 30, 40, 50% utilization in the project. So these are some of the tricks. I just gone into detail of one part of the 4P framework. And we'll go a little bit more because one of the things that many faculty get confused about is the difference between science and engineering and technology. I want to be very clear that science essentially is know why, okay? And essentially it is discovering a principle of nature or a cause-effect relationship that others have not discovered. And it's a worldwide phenomena. Anywhere you repeat the experiment, you get the same results. And you usually share such kind of knowledge through freely publishing in some journal. When I freely, I mean, these days we have to pay money, and no one pays money for us. But fine, the knowledge is free, anyone can look into that. Engineering is basically know-how. You want to use a scientific principle to actually visualize or think about a new product. You don't necessarily have to build the product, okay? But you say that this principle or science can be used to create a product like that, which solves a real life problem. And you want to establish your credit or ownership of the idea, well, you file a patent onto that. But that is still not commercialized. That is what technology comes to the picture. And you say that is show how to use this knowledge to actually solve a problem. So technology essentially is more like process of making the product with right quality and cost and so on. And you don't necessarily patent or publish the thing. You usually protect that as a trade secret because you want to slow down the competition and profit from your investment in the business. So what I like to tell faculty is don't stop at a publication, patent also. Protect your intellectual property right also. Don't stop there also, take it forward to a product, a minimum viable product which can be actually purchased by the customer. And don't stop there also, try to work with the industry to create a manufacturing process so you can make the product with the right quality at the least possible cost. And that is called as a quality management system for the process. But there's a caveat, file the patent first and then publish a paper, because if you don't do that, your publication itself will come in the way of your patent being granted. Patent won't get granted if you already published. So patent, you can file a provisional patent, and you can modify that within 1 year. And then within the 1 year, you can send your paper for publication. So that was it, research, a bit of a glimpse of research. We'll talk about education now. And let me propose that the foundation of engineering is basically science. As I mentioned, know why. Without that, you cannot really apply that. The basics of maths, physics, chemistry, biology, and you can add environment and even economics and computer science if you wish. But that is the foundation of engineering. Got to have good foundation. And many times arguments come in IITs and NITs that this JEE is actually spoiling the way students think. They only know how to eliminate the options in an objective question. But to be able to solve problems from basics is what science is, observation, experiments, and so on. And then engineering comes on top of that. As I mentioned earlier, it is know what, and then you have various branches of engineering. On top of that, we just mentioned know how. Again, if you want, you can say know how. Technology, which is these tools, which are basically tools and techniques, computer technology, computational technology, robotics, sensor technology. All these are enablers for making the products. But finally, to be able to create a success story in the market, you have to know management also. And that, let me use the word show how here. So you got to learn about finance and supply chain, marketing and human resource and so on. I want to share with you that sometime back in IIT, we had done a survey, and about 500 alumni who are into startups or entrepreneurs or industry professionals. We asked them one question: what subject you wish you had learned when you were a student at IIT Bombay, which you did not learn or we did not teach you, and therefore it became a handicap. And believe me, among all the topics that we talked about, creativity, management, ethics, communication, leadership, and so on, marketing, sales, and so on, finance came up right on top. It's very funny that engineers who can do Laplace transformations and partial differential equations are scared about finance or don't learn finance enough until it is too late. But beyond all those things, I believe personally that humanities and social science is a core which connects all of them. If our engineers do not know history and culture and philosophy and sociology and psychology and ethics, I think it is the entire engineering, we will be solving a problem and creating more problems and thinking about how to make money and not really look at humanities progressing in the right direction. So I believe that humanities as a core has to be part of engineering curriculum. And overall, if it also teaches us, because science is a certain, or science represents certainty. 2 plus 2 is always 4. In humanities, 2 plus 2 is not 4. Okay. So humanities teaches us how to deal with complexity. And engineers need to learn both, in my opinion. So we are therefore coming up with what I like to call as a balanced framework and a 4T framework, where we teach theory, which is know why, and translation of theory into practical products, which is your know what, and then tools and techniques to actually give shape to products and build them. That is technology for you, and then create success stories or take it to industry, testing, application, practice is the show how part of it. So if a curriculum, whether it's individual course or a curriculum as a whole, can have all the 4 aspects. I'm not saying equally 4 aspects, but at least elements of those 4 aspects is good. And if you're wondering where the humanities goes, yeah, that is a part of it. And that has to be maybe right from first year to final year. Some element of humanities or social sciences have to be part of the curriculum. And therefore, we are saying that if we can balance the curriculum, especially given the current students who are so distracted with the digital devices and in some sense fragile, we are saying that maybe they should spend as much time outside the classroom as inside the classroom. Again, anecdotal evidence, I talked about almost 200 alumni of NITK, one-to-one question. I asked them, sir, you are successful alumni and we look up to you and so on. Tell me what percentage of your success do you ascribe to in classroom theoretical teaching? I never got a number more than 50%. It's usually 20, 30, 40%. So we come to conclusion that maybe it is a good idea to balance theory and practice. And what we are saying is that maybe we should start with the foundation courses, basically science courses, prepare the student for engineering, get them interested in engineering in some sense. That is how we should teach the science courses and maybe some introduction to engineering courses. And then you go into the branch-wise core courses, technology courses, electives to deal with the industry sectors, because students can pick which sector they like, space or transport or energy or whatever. And then you can look at some electives to be across disciplines and of course, humanities and so on. But the interesting side is the right side. So if you say that labs can constitute 20%, and maybe another 20%, we are trying to propose, can we look at sports, which is for health and discipline, physical activities, cultural festivals or cultural activities, 5%, technical, which is DIY, which is building something physical with your hands, a robo, a car, a satellite, whatever, that is very important skill, and communication skills through professional events and activities. And another 10% reserved for, depending on the student's interest or career aspiration. If you want to become academic, well, do a R&D project. You want a job in industry, go for internship, because many internships do convert these days to job pre-placement offers. And if you want business, family business, or your own startup, well, do some entrepreneurship, business planning, and so on. And we also want to reduce the total number of credits and keep some additional credits for stronger students. Hey, you have more IQ, more CPU, well, take some extra courses and walk away with an honors in your own discipline, or maybe minors in some other discipline or an interdisciplinary project or area. So that is the rough structure we're coming up. It is not implemented, we're discussing, and I'm putting it across to you to think about this as a possible option to think about. One of the many things I mentioned was the theory to practice or translation. I cannot emphasize enough how important it is to put some kind of a team project or a course project in every possible course. The students work in teams to to bring to life some theoretical aspects to practice. Even if it's loose, they learn far more by talking to each other and solving a problem. And that, in my opinion, has to be done. It has to be well planned. You have to give the problems sufficient freedom for them to choose the tools and techniques. And of course, you have to get someone to judge the projects and so on. An exhibition can be held, or even a class exhibition can be held. All these are very good to assimilate, understand the subject. I can't say how important it is. Everyone should do this. And as teachers, we get very passionate about our own subject, and we want to push all the content into the student's mind. And let me convince you that if you say that there's an X amount of knowledge in any particular subject, and let's say you're doing research in the subject, you're expert in the subject, you're in multiple expert committees, even then, you spend some time preparing your notes to decide what to teach a student. Because finally you have some, let's say 40 odd hours in a typical 3 credit course in a semester to teach, and you have a lifetime of experience. So what do? So you bring down or prepare a subject, you make your own notes or slides or examples. And what a student does, he or she takes his own notes. And then finally you test the knowledge of the student in examination or a course project. And the student goes out of the institute and then he applies the knowledge into real life. What I want to convince you is that the pipeline of knowledge applied, if you look at it as an equation, knowledge applied equals knowledge available in the domain, and you yourself know only a part of it, but let's say knowledge available in the domain, multiplied by efficiency of preparation, efficiency of translation, both of which on the teacher side, and then you look at the efficiency of assimilation and retention, which is on the student side, and you put any number that you want. Preparation efficiency, maybe 50%, translation, I don't know, maybe 80%, put some numbers. And you will find that if you multiply all of them, it will finally come down to that 10, 20, 30%, which alumni have been saying is what we're learning from the courses. So my proposal for you to think about is instead of pushing more content into the students' minds through long classes, think about how do we improve these efficiencies. Can we teach less but more efficiently so they retain more at the end and apply that to real life? Think about this as a proposal. And of course, then you have the artificial intelligence. AI is really skewing the whole thing. We don't know what to do about it. Students are using that. Faculty have started using that. And we always tell them, hey, artificial intelligence versus natural intelligence. And it is a serious affair. I say natural intelligence, maybe we can define it as knowledge plus experience, which comes from life, plus intuition, which can't be explained, and the empathy for fellow human beings. That is what makes us human, or natural intelligence. It is not a question of AI versus NI, but AI and NI. And together is a way to go forward, at least at this point of time. And the role of empathy and ethics and so on, and imbibing that in the students through whether it is IKS, Indian knowledge system, or any other methods is supremely crucial at this point of time. So enough about education. Let us switch to innovation part. And we will say that, let me start by saying that the quotation that you must have heard about, that necessity is the mother of invention. And the question comes, who is the father? And when I asked the question to many people, the best answer I got was maybe curiosity is a father, and curiosity meets necessity, idea is conceived. But the point is, idea or invention is still a child, okay? And it has to become a product, which is an adult. And the process of converting or nurturing an invention into a product through innovation and entrepreneurship is what we call as the commercialization and impact cycle. And like bringing up a child, nurturing a child into adult, full of challenges, full of uncertainties, and expensive these days. But still, that is the way we have to go ahead. It will test our patience and perseverance, but a successful child or successful innovation, well, that's the price that you have to pay for that. So we have created a 4D framework, which starts from defining an idea, developing an invention, and then delivering, testing the solution in innovation, and deploying into real life through the technology readiness levels we talked about, POC and prototype and product and practice. And I must tell you that there will be a lot of failures on the way. From our own BETIC lab, the Medical Device Innovation Lab at IIT Bombay, we have had developed more than 300 different products to different problems, okay? And then out of that, we filed patents for about 70 odd, out of which 25 almost 30 got utilized in terms of licensing to a startup or an industry partner. But out of that, only about 12 have reached the market. Hopefully more will reach the market. And out of 12, about maybe 4 or 5 have become fairly successful in the sense they are selling in hundreds and thousands and more than a crore of sale and things like that. So be prepared for the throwing away ideas, which is good to fail earlier at POC stage than fail later at the market stage. So this is good actually. And this details out into how do you define an idea. There are some 8 steps. The primary focus there is that you actually go immerse yourself in the problem area. If you're solving a problem for the agri-tech sector, go talk to the farmer, live in a farm, look at the problems firsthand. Otherwise, don't do it. And then development is, most engineers know, the CAD and prototyping and so on. But that's where most people give up. But testing the solution or the product in the lab, in your accredited labs, getting certified, putting QMS in place, that is tough. In fact, I would say many engineers don't even know how to do this unless they're coming from industry. And finally, the licensing the technology to a startup or industry, getting the funding and putting the whole stakeholders together to create success story. That's the whole game from define to deploy, and we call it as a 4D framework, which we implemented in Betic very successfully, and the numbers which I mentioned to earlier are a result of this kind of process in place. What we learned from this process also is that 4 key success factors. If you take care of that, we believe that most of the failures can be prevented in this innovation game. First is that unmet need. Many times we think that people will queue up to buy the product, but you don't have enough sufficient evidence based upon actual market research. Go talk to people. These days we recommend talking to at least 100 possible customers or partners or distributors and so on. With a medical product, doctors and hospital managers and administrators and CEOs and nurses and even patients, and of course even competitors and shopkeepers and so on. So talk to people one-to-one, get the evidence, then only start the project. Second thing is, don't think about improving by 2, 5, 10%, because by the time your product comes to market, you have the scene has changed. So if you want to compete really and be visible in the market, you talk about blockbuster difference, okay? 2x, 5x, 10x benefit or impact, differentiation, okay? And then capability. If your idea is so good, but it takes 10 years to come to market, well, you already have the whole scene has changed. Can you bring the market in 1 year, 1.5 years, 2 years maximum? So it has to have the realization feasibility. Do you have the right kind of experts and things like that? And finally, a committed project team. If the team starts breaking up within a few months, someone says, I got a better job and I'm leaving. No, it's not going to work. People have to put aside anywhere from 3 to 5 years of their life and focus completely on that to create success factor. That is what it takes to create a success factor. There's no doubt about it. So let's go to the last step of entrepreneurship. And as a researcher, as a faculty member, if you want to translate your research and commercialize that, well, there are 4 options, okay? Depending on how much control you want and how much benefit or risk you want. Benefit, high benefit goes with high risk, and low benefit goes with low risk. So it's both are in the same horizontal axis. So, well, if you don't want too much control and you don't want too much of benefit risk, well, just sell your IP to an industry partner for a lump sum payment and forget about that. You don't care about what he or the partner does with that. Well, you want some control on it, or you want to benefit. You don't want control, but you want some benefit out of that. Well, you license it. You take a little less initial fee, but you say, I want a royalty out of sales. Every time a product is sold, you give me 2, 3, 4, 5%. Don't ask for 50%. No one is going to give you. It's usually single digits. Well, other way, well, you are a very noble soul. You don't want any benefit or risk, but you want some kind of credit or some control. Well, you can give it to a non-profit company, a Section 8 company, or a non-government organization, and give it free of cost, but you get something, hey, I need to be in the loop. I don't want any money, but you have to keep consulting me. But the best way, we want the best of both worlds, high control, high benefit, high risk. Well, you start a company yourself or your student, and if your student starts a company and you are a direct, you can be a non-executive director, you can retain your faculty position, but you don't spend time. You are only, you have shares, but you don't have day-to-day operations on the whole thing, but you can get some financial benefits. So these are the four primary ways faculty members can commercialize. And what they have to remember is that there's a long pathway from a startup to a scale-up. You have to go through SOPs, you have to look at stakeholders, and it's a long story. I'll maybe pick one aspect of those four S framework and talk about the business model. Many of you would be knowing about it, but to make it less confusing, I say there are only four aspects. The central aspect is what exactly is a value proposition. You must have heard the term, but what exactly is value proposition? Can you write it down in one line saying that for this problem, we offer this solution, which is, you can say 2x, 5x, better, faster, easier, whatever, but not cheaper only than the current best alternative or alternatives. That's in one line is what's called as elevator pitch. You tell a person and an investor, a partner, or whatever it is saying, how do you say it in 30 seconds? Okay, value proposition. The second one is that, okay, who is your customer really? And how are you going to reach the customer? Okay, so those aspects, what sector, what segment, persona of the customer, all those things come into picture. The other side is, hey, how do you build the product? Okay, who are your partners, your suppliers, vendors, your advisors, finance, banks, all these are partners, and what activities you'll do, what kind of resources you want. That comes into one of the four aspects. And finally, the money aspect of it, where you say, okay, what is my cost, which is cost to build the product, including other fixed costs, variable costs. We all have learned about it, but you have to put it into practice in a business plan or a business proposal, and the revenue part of it. And there are many aspects of that we cover in a longer version of this course. And one aspect I want to highlight is the funding part of scale up, because startups, we get funding these days for concept and POC and prototype. There's funding either from the institute itself, or you can go to government projects. There are enough government agencies which give you money to do all this. TRL 1, 2, 3, 4, even 5 you can reach. Okay, but then the game gets difficult. You want to build a minimum viable product and take it to market. That money you have to start looking at public-private projects. For example, for medical devices, there is a Section 8 company. It's a government organization, but like a private organization, which is called as a BIRAC. You can look it up, and they give funding even to take your product to market. But beyond 1 crore, the government money dries up. You have to start looking at venture capital, private equity, or you have to go to your IPO or acquisition by some bigger company and so on. All this game is there. You need to know the game, or you need to know someone who knows the game. And the main thing to remember here that as you, sorry, my screen has frozen. Okay, my screen got froze. Sorry. Okay. I hope you can still see the screen. So the game here is that as you keep getting others to invest more and more money in a company, you have to give up your shareholding. Okay. And as you give up more share and get investment, your company value goes up, but your operational control comes down. This is a valuable thing that you have to worry about. The speed of how fast you want to grow the company depends on how fast you're willing to give up your stake. Sir, all okay? Thank you. All right, just a quick check. All right, next we go to the entrepreneurship failures. There are many reasons of entrepreneurship failures. You can go to ChatGPT and say top 10 reasons of failures. But I'm looking at failures in Indian scenario. Having seen hundreds of startups, proposals, and scale-ups and all that, I can say the number one reason very easily is product market fit. The entrepreneur falls in love with the idea and say, this is front end, this will change the game. It will revolutionize the whole market. People will queue up to buy the product, and nothing happens because they have not done enough market research say that what exactly customer needs. Okay, so product market, the problem solution fit, product market fit are the terms used, but that requires good homework before you start even building the product. It is painful for me to see startups who are into 5 years and still sales are not started. They're still depending on government grants or awards and prizes. Hey, get me the sales revenue. Okay, so that is the first reason. Second biggest reason in India is core team fallout. 4 students who love each other, they're very good, friendly, same hostel or same hostel wing. They say, let's partner and start a business. But you need, first of all, complementary strength. Someone is internal looking, loves R&D, someone external looking, loves marketing, sales. One is good at finance, one is good at overall administration, operations. You've got to have different kinds of skills. Of course, you have to trust each other, no doubt. But then one of them leaves and the whole thing falls out. You get another person in, that person doesn't gel with the team. So team issues is major. So why to worry about that? The third bigger reason in India is that funding depletion. You have started getting the orders, the company is going very well, and now you have a big order of 1,000 products, but you need the money will come only after you deliver the product. You need money to build the product. You need raw materials, suppliers, you need to increase the team. Maybe you need a couple of crores or 5 crores. And where is the money? The money doesn't come. And that's it. Your company collapses. Your orders, but you cannot fulfill the order. And the fourth reason in India is getting out-competed. You think you are the first one in the world to come with that idea. You bet 100 others are thinking like the same thing. The guy or company which moves faster or gets luckier or maybe gets a big investment, they just move ahead and others have to follow. So these 4 reasons, and they can be taken care in different ways. I mentioned already in some sense. And the last one basically involve a lot of key opinion leaders, look out for competition and so on. And then you can basically hopefully take care of that. Having said that, most startups are likely to fail. And what we say, the startups fail, but the entrepreneurs don't fail. The entrepreneurs get up, start another idea, another business, and usually by third or fourth business, it is a success story. So I want to use a little bit of time to tell an actual story. I'm not sure how much time we have got, but I'll tell it in a very short version. This story is a very long story with 38 episodes. And this started when I met a doctor in a conference, and he invited me to see a surgery in Tata Memorial Hospital. The doctor's name is Dr. Manish Agarwal, and he's right now in Max Nanavati Hospital in Mumbai. And he invited me to see the surgery of a young boy who had bone cancer around the knee joint. And instead of amputating the leg, the doctor said, we are going to open the leg, preserve the muscles and nerves and blood vessels, only remove the bone around the knee joint and the bone around the knee joint, which is the femur and the tibia, and replace the entire thing with a mechanical joint. It was an adventurous event for me, very interesting event for me as an engineer, a professor of mechanical, seeing something. But this surgery was full of mechanical parts and instruments and all kinds of things. It was interesting for me. But then the question came up when the doctor said, why don't you build something like that in India? What they put was an imported joint. And so we got together, and I represented mechanical, Dr. Manish in the middle, representing ortho-onco, which is bone cancer. And we roped in Dr. Bala from Hyderabad, who was specialist in materials and manufacturing. We together designed a completely new design of the knee joint, a proper double movement, both flexion and extension like a knee joint, also a little bit of rotation around the vertical axis to minimize stress and give the flexibility to the knee joint. And prototyping the high-end space materials, a modular design so the parts can be mixed and matched because every patient will have a different size and shape of the tumor cancerous portion. So we had to mix and match. And we set up the manufacturing unit in Hyderabad and FTDC. The first batch of products coming out, of course, it's a minimum viable product. You should see the happiness on the entire team who worked on that. TKP is a tumor knee prosthesis. So TKP large, TKP medium size, and so on. And then the doctor said, no, I'm not going to put the patient unless you build a machine to test the joint. How long? To 5 million cycles, which is equal to 5 years of walking. And we built a machine also. Machine started failing. We built another machine, which eventually took the joint to 10 million cycles, 10 years of walking, which was more than sufficient to prove that the joint that we had designed and built was way safe for putting in the patients. Then the doctor said, well, what about the instruments? Because your design is different. I can't use the standard instrument. You have to design the instruments also. In fact, our first patent we filed was the innovative instrument for doing the surgery. And finally, the day came, this will fill a large or 2 large dining tables. That many instruments are there for this surgery. And then by the time I got a little worried, so I said, no, let me also build a software to plan the surgery in 3D. So from some CT MRI scanning data to 3D model to bone thickness to cutting the bone virtually in the software and then seeing which parts will fit and then how to see how the after fitting, how it looks like, all the things we built in the software called orthosis. And finally, the day came in 2019 that we got a patient. The funding came from Government of India, and the patient would get, after consent, of course, a completely free joint, and of course the treatment and so on. And the first patient came in, and you can see what you see in the leftmost picture is the knee joint, but right after the knee joint, I don't know if you can see my cursor, is the tumor portion. And that's this whole white portion is a tumor portion. Big one, is bigger than an apple. Okay. And the next picture, if you can't see, just I'll pass it fast. That's how it looked like after we put the joint in the human body. You can say human body is beautiful, also ugly, but look at the joint, and that's so beautiful, and it is going to function as a knee joint. I'll skip that picture and go to next one, which shows an X-ray. And you can see that there's no knee joint in his body. The entire knee joint is replaced with a mechanical joint, including part of the femur, part of the tibia. And in case you're able to see the video, you can see how well the patient is walking just a few days after surgery, not weeks and months, just a few days after surgery. This was the first one in 2019. And to summarize, 2004 is the first time when I saw the surgery in Tata Memorial Hospital. And 19 was the first joint that we built. It took us 15 years to build the whole joint, design, manufacturing, testing, the instruments, the software, and getting funding, second level of funding from Government of India to build about 100 joints and give it free of cost. Till date, I just talked to the doctor last week, and he said 80 joints have been placed in the end, not a single failure of the joint. I mean, these are cancer patients, some of them die because of cancer, but the joint has not failed in any patient. So it's one of the indigenous success stories, you can say. Of course, we got a lot of publicity. We got an invited paper to tell the story about this whole thing, and you can just look it up with the keywords world-class tumor knee processes made in India. And we presented that to the principal scientific advisor at that point of time, Dr. R. Chidambaram. He's no more, may God bless his soul. We gifted to him, he was very happy. But that day, Dr. Manish made a statement. He said, I want to use an Indian product, an Indian joint, not because it is cheap. Of course, it is cheap also, but not because it is cheap, but because it is the best. And that has become our motto, to develop the best products in India, which are the best in terms of quality, materials, manufacturing, every aspect. But, and of course, because we're Indians, we also give it at low cost. Believe me, the world is looking up to India for delivering and showing the way in innovation and entrepreneurship. So we talked about 4 aspects: research, education, innovation, entrepreneurship. The short form is reinvent. We have the 4 frameworks: the 4P framework for research, 4T framework for education, 4D for innovation, and 4S for entrepreneurship. What I've given you in 1 hour or less than that is a glimpse of that. I usually run an 8-hour 9 to 6 workshop. In fact, I'm going to do this day after tomorrow in local college here. And anyone is interested, I'm happy to do that, because I believe that our teachers should see that it is possible to do and connect the 4 things and make an enormous impact. But more equally important, the kind of happiness and content that you see by connecting those 4 things, looking at your research, making an impact. I can't tell you, it is way beyond happiness. So we need these faculty champions. And at NITK, I've been telling faculty, yes, you start with your teaching and research as a foundation, but then you start teaching others also to continue education. Your research, you use it to solve industry problems, okay? And then you look at take it beyond to workshops. Other side, you go into prototypes and patents. As you become full professor, look at, can you create a new center of excellence, international conference? Other side, you see whether you can license your prototypes, start looking at industry consortium and startups. And once you go to a senior professor, of course, make a difference, put systems in place where all this can be done by the younger faculty, and of course, thought leadership. So there's a pathway that we are trying to implement at NITK. And finally, the ecosystem that is implemented is a circle. I showed you a line from POC to prototype and market, TRL 1 to 9. My recent insight is that it is actually a circle, people to people, and you go in a clockwise from 1. So go to people, talk to people, and find out what problems they have got, solve the problem through your research, use a prototyping center to create actually a POC or a prototype, okay? Set up a pilot manufacturing. Your workshop may or may not be good enough, or go to local industry, put some MVP, build some MVP, 10, 20, 30 pieces, give it to people, test it in the lab and test it in accredited labs, okay? And create a startup. Don't create a startup and then build the products. Build a product, and then once you have visibility of some person saying, hey, I want to buy this, That's the time to start a startup. I want to see sales revenue in year one of a startup. Sales revenue, not awards and things like that. And then, of course, go to accelerator, business park, whatever, scale up. And then when you go to market and get the feedback from the customer and you're touching the people again, you get to more ideas to solve more problems or more new versions of your product. That circle has to keep going. And I think I tell you, it's a golden circle and a beautiful experience by altogether. Finally, I would like to mention the stakeholders. This ecosystem cannot be built unless you have, let me start with government, which does funding and regulation, academia, which does research and development, industry, which does manufacturing and marketing. And people say triple helix. Oh, what about the fourth one? Equally important. Society. Talk to people. Society is where you identify the problem worth solving and go back to them to validate your solution before you do a big startup and business and all those things. Not enough for other stakeholders. Incubators play a very important role, a soft landing from academia to real life industry, which is very lethal and brutal. Accelerators, which further take the journey from startup to scale up. Then investors, because of the funding depletion, you remember, when you need 1 crore, 5 crore, 10 crore, you need those investors. And then finally, media. You got to know the game of how to use digital media, social media, website, of course, all those things because people have to know about your product. So these 4+4 stakeholders together is what is necessary to create the reinvent ecosystem for taking your products all the way. So I conclude here. This is a picture of NIT Karnataka Surathkal. You're most welcome to come anytime. Enjoy our hospitality, our weather, our beach. But why I showed also is that we are trying to implement some of the ideas I discussed with you in this place. And of course, we will know, time will tell us how much successful or what worked or what did not work. For me, it's an experiment. But thank you very much for being patient and some of the comments in between. Thank you for your kind words. I am now ready to take some questions from you.
Thank you, Professor Ravi, for a very elaborate and talk covering almost all the critical dimensions from an academic institute point of view. Now I'll open the floor for any questions or comments from the.
So can you read out you want to pick some questions, Professor Sudhir?
Yeah, I'll start with one question, which says, is it better to pursue a patent first or to find pilot customers for validation and iteration?
A patent first. And the patent is of two types. Provisional patent you can file as soon as you have a sketch and the basic idea. And you get 1 year to file the what's called as complete specifications or the final patent. And that 1 year you can do publications, your pilot manufacturing, testing, all those things. Because the moment you put the product out in the market, someone can always copy. It is good to patent first.
Professor Mishra, you have any question?
Yeah, good evening, everybody, especially Professor Ravi. It gives me immense proud that one of my alumni has done so much things. You can't imagine how proud I am now. And also regards to Professor Patak sir. I want to have one knowledge, one information that how do I inspire the PhD holders, those who are PhD students, to go for startups? My experience says that they are only coming to get some funding, some kind of seed money and go ahead. And off the record, many faculties are also some mentality.
So
how do
I'll answer it in a funny way. There was a meeting sometime back. I think I don't know if Professor Sudhir was part of that meeting or some other, where they discussed a lot about the ecosystem in academic institution, about how faculty and even researchers can create deep tech startups. Somehow I was distracted and suddenly someone asked a question to me, Professor Ravi, what do you think? And I was not paying attention, like an online meeting like this. And then in one word, I said, I have only one word answer. It is about mindset. And then the whole discussion changed after that about how do we change the mindset of faculty and students. So this session itself is for you is meant to change the mindset of faculty and students. And I have taken upon myself to actually travel to every NIT, covered now Calicut and Surat and I think Jalandhar. And I'm going to Warangal next end of this month to basically run this reinvent workshop so that at least faculty should know there's a possibility of doing that. open their eyes. And administrators at at the institute level, director level, dean's level, how to create the ecosystem that I talked about. I mean, what I talked about is very brief. There's a lot of fine detail to the whole thing. But putting the systems in place and creating initial 2-3 success stories and publicizing that is a starting point. You got to start at some point of time.
Professor Ravi, we have 3 or 4 our startups from our students. They have now reaching 100 crore valuations. They are doing really good in India.
Fantastic.
But faculty driven, we are lagging.
Sir, let me be very kind.
Is it outline in your itinerary?
Sir, let us be kind to the faculty. Why do you think faculty join the academic institution? Because they don't want to go into business and industry and money minded and all that. No. And now you're saying you please make money and do innovation entrepreneurship. Sir, faculty, they are not trained. The mindset is not like that. So don't think about all faculty doing that. All you need is about 10, 15, 20%. Good enough. And you will find some of those who change their mind or get inclined or get inspired. That's all you need. Okay, and set up a system to take those POCs to prototypes to MVPs. That's all you need. It's possible. It's not difficult.
Is it outline in your itinerary? My last question.
Sorry?
Is NIT outline in your itinerary?
Oh, yeah. All NIT, sir.
Okay.
Sorry,
Thank
we are
you.
starting to run long. We'll give others a chance to ask questions. Go ahead, if anybody else.
There is a related question in the chat. I'll just read it out. As a new faculty member, how do we manage time to do so many things? How do we allocate time wherein we have to balance between teaching, research, projects, innovation, and so on?
That was already answered in one of the slides where I showed a pathway. As a new faculty, don't get into all those things. Just build your basic foundation of good teaching and good research. Start guiding some students and so on. Then you start making proposals, so on. There's a very good pathway. And as you build the foundation, you start becoming more efficient. You get more resources, and therefore you can start building those, as I said, go into this whole thing. You don't have to start innovation entrepreneurship on day one of joining an institution. First, build your foundation.
Professor Phatak?
Yes.
Yeah, this exactly, it's excellent lecture. Not only the subject matter, that work personal as well as the way of teaching, and the slides are really very exciting. You got highly benefited. One question I had, that equation for knowledge pride, it's excellently put it. But what I will feel that maybe the right hand side will have to have a multiplying factor, that institutional factor, exactly when certain achievements and some good work comes in, it gives others also inspiration. And where the institution, because of the politics, because of the other things, goes down, when the laboratory teachers suffer, when the right support is not given, then when the industries are not properly handled because of that, that factor exactly ruins many faculty, even though they have their very good innovative idea, industry contract, but cannot because of the institution factor. And while administrating the institution, that particular matters a lot. And we have, I think, the way IIT Bombay, I have seen in their research park when they're having so many medical products, even for the Alzheimer's, that knee and things like that. So this is exactly there is a very good institutional factor, that same which is there also at the research park of IIT Chennai.
Yes.
That institutional factor exactly encourages, and where the institutions where the new teachers given number of load, and then where they are exactly the new teachers are encouraged to give elective subject than the main core subjects teaching, those type of institutions, the faculty come and then they do not develop their diagonality and do not develop their horizontality. They just come with a one particular research area, in that they want to, and then this type of development comes only with the multidisciplinary things. That is my observation. Thank you so much, sir.
Welcome. Thank you very much.
Yeah. One other question here in the chat is, how do we motivate students to convert their research in BTech or MTech or PhD into an innovative technology or entrepreneurship?
It's not a single thing. It's like a bundle of things. I mean, you call some great alumni, you can always call who are successful entrepreneurs. Let them talk to the students. Facilities for converting, building basic prototypes. Faculty not telling students, don't waste your time. It's too complex. Someone else will do it. All those negative things, don't do that. Even if the project is going to fail, let the student fail, because you learn more by failure than succeeding in this kind of a thing. So all that little bundle of things, hundreds of things. That's what ecosystem is the meaning of the word, right? So start one of the easy way to start is to get young alumni who are successful in the startups, and that's very, very motivating to students.
Sab, you have any question to?
Yeah, thank you very much for a really wonderful lecture. I think one point you mentioned a couple of times, which I think needs more emphasis in our culture, the non-acceptance of failure, that we have to start teaching our students that failure is the building block for whatever you are doing, and it is nothing to be ashamed of or hidden. Even I've seen teams fall apart in India because people are hiding failures from each other. Okay.
There's one point I want to just interject there, because there's one question about why it took 15 years to develop that device. It's precisely because of that we faced so many failures on the way. I mean, funding got over, the team got changed, the regulatory regime in the country changed. There was a new regulation of medical devices, and so on and so forth. All kinds of problems, and I can say there were 50, 100 failures in the project. The only thing what we did was persevere, and so it took 15 years, but at least we are successful. But failure is stepping stone for success. I vouch for that. In fact, failure teaches us a lot of things.
I think this is where, from your experience or other people's experience, cataloging the way things fail, why they fail, and failure as an integral part of our thinking, I think that needs to be developed in the curriculum itself of innovation, prototyping, etc.
Correct.
And the other point I want to make is that there may be institutional mechanisms. For example, I think innovation happens at the interstices of discipline, which you correctly pointed out with BioX, and there are so many X's and Y's which you can put together. If we can encourage our faculty to look for problems which are common across disciplines or at the interstices of two disciplines, you have a rich area which is unexplored often or underexplored, which gives you new potential. I'll just give you a quick example. At CMU, what they did was, whenever you got a grant to an accounting device, whenever you got a grant together with another person, then both departments took credit for it. Okay, this was a very important institutional mechanism whereby people were not fighting with each other. Half of my grant is yours, and not in terms of money, in a conceptual sense, they were equally rewarded. You see what I mean?
Yeah.
So that created openings over and over again for people to reach out and create new spaces in an academic sense, which eventually translated to products and things like that. So Thank you very much. I don't want to take much time more, other than if anybody else has a quick question.
So one question which could be related to this interdisciplinary interaction. Essentially, the question is around, when you interacted with medical professionals, did you face any resistance and how did you deal with that? This could be generalized into a common question: working across disciplines, how do you build rapport across? Maybe you can.
No, this is always there, that you are looked upon as a foreigner when you enter a field. And I did have resistance from our own faculty in IIT Bombay, and also in the beginning, they just don't trust you. So it is very, very important to build the trust, and you become friends first, start talking to them, have coffees with them, and it sometimes takes multiple meetings over days and weeks and sometimes months. But once that they know that you mean well for them, then the doors are open, wide open, and then you can walk into all kinds of places. I mean, I can say that I have friends in almost virtually every top hospital in Bombay, top doctors in top hospital. So, so you will face resistance definitely, but if you go with good intentions, in fact, good intentions will open doors which you don't even know exist. And I'm making a very general statement, but I have in an 8-hour session, we talked about a lot of stories which you can almost say, hey, how did this even happen? Was it a miracle? But miracles do happen when you go with good intentions.
Okay, any other?
I want to make one point. I think your program is great, but you might want to collaborate with arts colleges around, even industrial arts or traditional arts, to be part of some of these courses, project courses.
So
one of the courses.
Let me say that. So actually, I don't know the composition of people in the room today, but when we do this reinvent, we say it is for 40, from 40, under 40, which means 40 people who were under 40 years age from 40 different disciplines. I mean, sometime in one of the events, I had pharmacy, I had legal, I had financial, I had management, I had medical, dental, of course, engineering, all branches and so on. So I want 40 totally different people. And that session is, I can't tell you, it's like beautiful. And they're discovering first time these people, each other's, interest and domain, that become friends. So the after effects are very interesting. First time you opened up the possibility that, hey, we can talk not just weather and children, but actually real life projects and problem solving.
Yeah. You're building a community of knowledge. And I think this is an important part of the evolution of innovation. And I can tell you more. There's a very nice book called Innovation as a Social Process, which describes the evolution of the electric industry in the US.
Right.
So you'll find it quite fascinating. Anyway, thank you very much from my side.
Thank you. Thank you all.
So I think we have taken more than your initial time. But thank you very much, Professor Ravi, for taking time and speaking to the audience. We will be recording and posting this on the CRE channel. So anyone else who has missed out also can look into this. Also, I've sent you a mail regarding the CBD workshops that we are planning.
Yeah.
So we'll be wherever you can find an alignment with your time, please let us know. We'll be happy to include that as part of the workshop. So thank you very much. And thank you all the participants also for joining the session.
Thanks to everyone. Good day, good luck.
Can I ask you a question?
Sure. Please
Can I ask you a question? Can you get one of your documents to talk? That would be wonderful.
I can do that.
Given that you've got assembling different kinds of disciplines, it would be nice if you can point us to those people who can give a talk in this forum.
Sure. Done, sir.
Great.
Okay.
Thank you so much.
Thank you all.